Hello friends, welcome back to my channel. So today we are going to discuss another LeetCode problem, and the problem title is unique paths 2. So basically what is given in this problem? So here we are given a two-dimensional matrix, and what we have to do is we have to traverse from the starting position, that is a 0 0, to the ending position, that is a mn, or if you consider the 0th index, so it's like start position is 0 0 and end position is m minus 1 n minus 1. Okay, so from basically from the top left corner to the right bottom corner we have to traverse, and basically in this we are given one extra case, that is we are having some of the obstacles, like it can be like 0 to many obstacles we can have over here. So whenever the robot detects the obstacle, so you cannot go further, and like that is a end point, like it is a breaking path, so you cannot move further from that position. Otherwise what robot needs to do is robot can either go to the right of it or go to the bottom cell. So it can go to the right cell or to the bottom cell. So these are the two choices we have over here. So basically though it is a medium level problem, but the intuition is very straightforward, that like we are having the two choices. So at every stage we need to have the two options, like every time it can be like if you consider I as a row and j as a column. So for the first time, so increment the j by 1, so that I remains same and j plus 1, and at this for the second choice we have to increment the I, that is I plus 1, and j remains same. So that's the whole idea over here. Now let's come to the coding part, and again like what we have the output is asked for, we have to find out the unique paths. Like so if you consider if you go let's take an example over here. So here if we see, so in the example 1, so here we can go to this 0, then this like we can go to the right, so like from 0th row for 0th column to the last column, that is a 2th column, and again from this 0 we can go in the downward direction 0 0 0. So finally we reach over here. So that is one of the possible path. Now another path is like instead of going to the right, we can like go in the downward direction from the starting position. So this 0 0 0 gets executed, and from this bottom row we can move to the right side. So this way we can reach to the bottom right corner. So that's why the output is 2. So let's get into the code part now. So here we are given a function unique path with obstacles. So here the input parameter is two-dimensional grid, so it can have the value as a 0 or 1. So what I am doing over here is simply I am calculating the number of rows first and storing into the m variable. Similarly I am calculating the columns over here and storing into the n variable. Now like if I go with the plain recursive approach, so the time complexity will be 2 to the power n, and in this case it will give me the time limit exceeded for one of the large test cases. So to avoid that, what I am doing is I am simply using the memoization with the 2D matrix. So whatever results are pre-calculated, so I can directly pull those back if it is already calculated. Okay, now after that what I am doing is I am starting from the 0 0th location, and my end location is mn, though it is mn, but in terms of like it is a 0th base index, array is 0th base index, so my last position should be m minus 1 n minus 1. So that is the point where I need to stop. So here I am calling the simple DFS function. So it has the 5 parameters, that is a grid, then start position, and the end coordinates. So in this DFS function it returns the integer. So basically it sums up both the results, like if I go in the right direction or if I go in the downwards direction. So it clubs the sum of both the results, and finally it returns over here. Okay, so the first base condition is the out bounds or outer bound. If my I or jth value is lesser than 0 or it is greater than or equal to m or n, so in that case there is no path existing, so that's why I am returning 0. That is a simple base case. Now next thing what I am doing over here is, inside this, if I reach to the bottom right corner, so in that case my I has to be m minus 1 and j has to be n minus 1. So again, like one more special case we need to consider, if we have only if we consider the one row one column matrix, that is only single element, so that time we have to make sure it is not 1. If it is 1, then at that time it should return 0, that means there is no path existing. If it is not the case, we are simply returning the 1. So every time, like whenever we traverse the full path, so every time it will keep on adding the 1, because the last thing at the last point we are returning the 1 value if it has drawn the path successfully. Now next step what I am doing is, if I find an obstacle, that is a grid contains the 1 value, so I simply need to return with a 0 value, because I cannot go like further to the right direction or the downward direction, so that's why it returns the 0. Now next thing is, I am checking whether the result is pre-calculated, whether with the help of this memoization. If it is not equal to 0, then I am simply returning the memoized value for I and jth index. And after that, this is the main case where we are calculating the values for both the choices. So here for first time I am keeping the I as the same, and I am doing the j plus 1, so I am moving in the right direction with the DFS call. Similarly, I am doing the addition over here because I want to calculate the number of unique paths. So for the next DFS call, what I am doing is I am going in the downward direction, so that's why I incremented the I value by plus 1 and j remains same, so because in the same column. And finally I am returning this memoized value for that ith and jth index. So that's the whole idea over here. So main part is basically it should perform both the choices, go to the right direction and go to the downwards direction. So here we have got the output as a success. Now let's see the test coverage part over here. Okay, so here it has passed all the 41 test cases over here. Now coming to the time complexity and the space complexity. So in terms of space complexity, we are forming the memoize table, that is a 2D matrix, so it is a m into n, that is a space complexity. And in terms of time complexity, I am bit skeptical, but if I see, so at every iteration we are making the two choices, like to the right and to the downwards direction, so I think it is m into n, that is a time complexity. But again, if you have any suggestions, so please drop me a note in the comment section and I will respond to it. So and I have posted the solution for this in the description section below, so you can refer to that GitHub link over there. And that's it for now. Thanks for watching my video, and please like and subscribe to my channel, and stay tuned for the next one. Thank you.